Okay. So, okay, it's an a plus bi for I is the square root of negative 1. A and B are real numbers. You've seen this before. You can't have gotten through Algebra 1 and Algebra 2 courses without seeing complex numbers. If you did, there's something seriously wrong going on out there, but I don't think that happens. You might have forgotten about it, but you've seen it. That should be familiar. If it isn't, it's simple enough. Okay? So, how do we multiply two complex numbers? Well, five plus 3i multiplied by 4 minus 2i. How are you going to multiply these expressions? What rule of mathematics are you going to use? Distributive law. So, and you've seen me do it many times. It's 5 times 4 minus 2i plus 3i times 4 minus 2i. And then we use distributive law again, because that's how you multiply binomials or trinomials or multinomials, okay? So we have 5 times 4 is 20. 5 times negative 2 is negative 10, and you've got the I on that term. And then it's 3i times 4, which shouldn't surprise you, is 12i, minus 6i squared. Okay?
Okay, I get that. That's fine.
Yeah, so this, as I say, it's simple, until you get to division, which is a little tricky. Okay? So, there we have it. Okay, now, I squared is what?
Positive 1.
You're close.
Negative.
What do you get if you multiply the square root of negative 1 times the square root of negative 1?
Negative 1.
You get negative 1. Okay? It's not written very well. If you multiply the square root of a number times itself, you get that number, right? So we can say this is 20. Now the negative 10i and the 12i add up to 2i. And then it's negative 6 times I squared. I squared is negative 1. And not skipping any steps here. That gives us a plus 6. And we find that it's 26 plus 2i. Okay? Any problem with that? If you do the steps carefully, there shouldn't be any problem at all. It's pretty simple. But you got to be careful. That's the main thing. You got to know what I squared is. Okay? And then you just got to do your steps one at a time. Careful. Okay? Addition is even easier. Let's take the same numbers, 5 plus 3i, added to, what's the other, 4 minus 2i, is, well, it's 5 plus 3i plus 4 minus 2i, which is 9 plus 1i. Any mystery there? Now there's official, commutative and associative law stuff, but that's okay. We've got a string of additions and subtractions. We can just rearrange, okay? That's not something that gives people much trouble. So you should know how the commutative and associative laws make that possible, ideally. but it's not absolutely necessary to put this in the course. I'm not going to test you on it. Just advise you that it's a good thing to know. So I do recommend it. Okay, so that's easy, right? Now let's say we want to divide these. Lots of exclamation parts around the knot in case you were prone to miss it. Okay? If I'd have been thinking, I'd have written it something that flashed, but I don't have this flashing chalk today. Okay. It's not this. How can I prove that it isn't? This is easy to prove. If it's so, if this divided by this equals this, then this has to equal this times this, right? Like 6 over 2 is 3 because 2 times 6 is 3. 2 times 3 is 6. Okay? So why is 6 over 2 equal to 3? Because 6 equals 2 times 3. Okay? So if this over this equals that, well, in general, A over B equals C. If and only if A equals B times C. That's what division means. It's actually not the deepest meaning of division, but symbolically, that's what division is. Okay? So, if this was equal to this, then this times this would equal this. And it ain't. And I leave it to you to multiply that out. That'll be homework, okay?
Oh, no.
If you multiply this by this, it's not going to work out. So this divided by this can't equal this. Okay? And you're unlikely to discover a scheme as simple as you'd like it to be, that looks like you think it ought to look like, that makes it so. So here's what we have to do, and it's very simple. Well, let's keep this up here. Okay? Okay, we're going to multiply this by 1. But the 1 that we're going to multiply it by is 4 plus 2i over 4 plus 2i. Now, how did I get 4 plus 2i? I took what's called the complex conjugate of 4 minus 2i. We changed the sign of the I term, okay? So you see how this is related to this, right? Now, you know from algebra I say you know, but I'm afraid a lot of people don't. And I haven't emphasized special products that A plus B times A minus B is A squared minus B squared. Now you can use the distributive law and see that the other two terms cancel out. I used that bad word. Okay, they add up to 0 and they go away. And you can prove that. And I'll probably ask you to do that for homework. But it's simple. Okay? So we do this. Well, what this is going to equal is, and I'm just going to put some dotted lines here, you do the arithmetic, and you get 20 from this, and you get -6 from this, that's 14, and then you get 12i and 10i, which is 22i. I did that right. That's okay. And 4 minus 2i times 4 plus 2i is 16. I'm going to write it as, I'm going to write a step here. 16 minus the quantity 2i squared. Because if you understand this, you understand that this is an a minus b times an a plus b. It's got to be a squared minus b squared. But you can do the distributive law, and that's what you're going to come out with. Okay? The terms with i's on them go away, and the denominator can't see a thing anymore because the i's are gone. Okay, don't know if you're done with that, I'm probably thinking. But anyhow, that's, the i's go away. You have a blind denominator. Okay. And that equals 14 plus 22i divided by, well, you square 2i, you get 4 times I squared. I squared is -1. Okay, so you get -4 when you square this, but it's negative, you're subtracting it, so it's +4, so that's over 20. Now your book will show you this, but it's all very simple. Okay, you see examples, go through the examples, write them out, and write out a bunch of problems. And I find that when I give a test and ask about the operations and complex numbers, people nail it. Okay? Anybody who's passing nails the complex numbers. Okay? Anybody who's passing the other stuff nails complex numbers. One of the easiest things in the course. But you got to practice with it. So anyhow, that's 14 over 20 plus 22i over 20. Right? And that reduces by steps that you should show so you don't screw it up. 7 over 10 plus 11i over 10. And then if you multiply this by this, you're going to get this. So we check, which is a step that people tend to always bypass. Solve the problem, you have no idea whether you got it right or not, you don't check, so you don't know. So you don't go back and fix it, so you don't learn. Okay? You want to get in the habit of checking everything you do. Well, when you got a lot of problems, you maybe don't have time to check them all, but be sure you're checking enough of them to know that you're doing it right. Yeah.
Okay, so how do we get 14 plus 22i as our numerator?
You fill in the dots using the distributive law. So I'm not going to show you that just for sake of time and because there are other things we've got to talk about. It's something you won't have any trouble with. If you just do the distributive law on the numerator, that's what it's going to come out. Okay? Now, but let's make sure I did it right. Let's check this. Okay?
What a blessing.
Okay? Is this times this equal to this?
Okay. I know you look at me funny. Do we have to write it like the 7 over 10 and 11 plus 11i over 10, or can we just leave it as 1?
Leave it as 1.
Like this? Like leave it as 1 fraction, split it over.
I want to split it
That is
up.
multiplication.
You got to know what the real part is and the imaginary part. So you can't just leave it like this I want to see what the real number is, what the imaginary number is, okay? It's not because I want to see it, it's because you need to know that. That's important. So this is just distributive law. You know, this is like this multiplied by 1/20th. Well, it's 1/20th of this then plus 1/20th of this. Okay?
Okay.
Anyhow, let's check this out and see if I did it right, because, you know, I'm prone to make arithmetic errors. I think I was careful, but yeah, I did that distributive law step in my head. So, you don't know, I don't know, let's check it out. So we get 4 times 7/10 plus 11i over 10 minus 2i times 7/10 plus 11i over 10. Is that equal to 5 plus 3i? Now, if I don't make a mistake in this, and I didn't make a mistake in this, it's going to work out. So let's be careful. 4 times 7/10 is, I'm going to write it as 28/10. I'm not going to reduce it, because that's going to put everything in tenths. If I start reducing things, some things are going to be in fifths, some things are still going to be in tenths, some things might even be in halves. So we get then 44i over 10 minus 14i over 10 minus 22i squared over 10. Is that equal to 5 plus 3i? Well, we take care of our numerators. The negative 22i squared becomes a plus 22. So that's 28 plus 22 over 10. And things are looking pretty good because that adds up to 50. And 50 over 10 is 5, and 5 is what we want to get for the real part, right? Okay? And then it's plus what? Okay? And that gives us this, and in the next step this becomes okay, and it works out. Now you just have to work that through for yourself. It's easy, but there's some steps. But you have to see that it works out, and you have to do enough problems that you're used to the way it comes out. Okay? And then you've pretty much mastered the arithmetic of complex numbers. Now there's much, much more to complex numbers. It's only the beginning of the whole field of complex analysis. But that's something you don't get to until you've had 2 years of calculus and a year of advanced calculus. Okay? So most of you don't have to worry about theory of functions of complex variables. I worried about it from my junior year of college all the way through graduate school, because that's what I kind of majored in. Is my chosen field. So it goes a long ways, but this is a good start. Now there's more to it. There's De Moivre's theorem and stuff like that. I got to look twice to see if your book even does that. Okay? I'll maybe take a look right now. I'd love to do it. But we're not going to do it until you got the arithmetic down. Okay?